How do you think this boat is being propelled? There's no motor and there's no sail. It turns out that when we add soap to the end of this toothpick and place the toothpick in the water, something called the Marangoni effect pushes the boat. What is the Marangoni effect? It is caused by a special property called surface tension. Surface tension is the tensile or contractile force on a surface. It acts similar to a stretched elastic membrane, kind of like a balloon. Every portion of the surface is pulling in on itself with a contractile force. If a liquid has a high surface tension, it means that this contractile force is high. What happens when you put a drop of liquid with a low surface tension in a bath of liquid with a high surface tension? Let's use water and soap as an example. Water has a high surface tension, while soap has a low surface tension. For each liquid, there's a contractile force on the surface. But since water has a higher surface tension than soap, the contractile force on the surface is bigger for water than it is for soap. In other words, water surface tension will pull more strongly than soap surface tension. This results in a net force from regions with low surface tension to regions with higher surface tension. This net force causes what is called the Marangoni effect. The Marangoni effect says that fluid will want to flow from areas of lower surface tension to areas of higher surface tension. We can see an example of the Marangoni effect by adding pepper to water. There's soap on the end of this cotton swab. Watch what happens when the cotton swab is put into the water. The pepper flakes move away from the point where we added the soap. We can also see the Marangoni effect cause this string to expand when we add soap to the middle of it. Fluid is flowing away from the region of low surface tension, that is the region with soap, causing the string to expand. Now let's look back at our soap-powered boat. The Marangoni effect is what is causing the boat to move. Let's look at a force diagram. As we learned before, the Marangoni effect states that fluid will flow from the soap region towards the water region. There's fluid coming out of the back of the boat because of the net force between liquids with different surface tensions. The fluid coming out of the back of the boat is what propels the boat forward, kind of like how rockets eject gas to propel forward. This kind of propulsion works because of Newton's third law, which states that every action has an equal and opposite reaction. The action of the fluid coming out of the back of the boat produces a reaction in the opposite direction, propelling the boat forward. Why don't you try making your own soap-propelled boat at home? All you need is scissors, cardboard, toothpicks, water, and soap. The cardboard should be somewhat waterproof so it doesn't soak up water. The sides of a milk carton or juice box should work fine. Cut a boat shape out of the cardboard. Then, cut a channel shape into the back of the boat. You can try different channel shapes and see which shapes work better. Next, place the boat carefully in the water so that it's floating on the surface. Put soap on one end of a toothpick and put this end of the toothpick in the channel and watch your boat go. You can also try different liquids and see which other ones can propel your boat.